Welcome to the session on exponentials and logarithms, solving equations using logarithms. The objectives for this session are to solve equations of the form a to the power x equals b. Exponential functions, recall, are functions of the form f of x equals a to the power x, where a is a constant. The inverses of exponential functions are called logarithms. So the exponential relationship, a does not equal 1, a to the power x equals n, can be written in terms of a logarithm, log n base a equals x. Let's now remind ourselves of some of the laws of logarithms: the multiplication law, the division law, the power law, and the other results or derivations. Using logarithms and your calculator, you can solve equations such as a to the power x equals b. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's now solve example 1a. We are required to solve 7 to the power x equals 89 and give our answer to 3 decimal places. So let's solve this. Now 7 to the power x equals 89. And from the colour codes we'll easily be able to see that a equals 7, x is of course as it is, and n is equal to 89. And this will imply that log 89 base 7 equals x. Using the log button gives us that x equals 2.307 to 3 decimal places. We can check that this is correct by plugging in 7 to the power 2.307 and checking that it equals 89, or approximately 89. Now let's have a go at example 1b. We are required to solve 3 to the power 8x minus 3 equals 63, giving our answer to 3 decimal places. So let's solve this. If we colour code, we can see that log 63 base 3 equals 8x minus 3. And using the log button, we find that 8x minus 3 equals 3.771. Using our calculator, we can then check that 3 to the power 3.771 is approximately equal to 63. And so, rearranging gives us 8x equals 6.771. And therefore, x equals 6.771 divided by 8, which is equal to 0.846. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. We are required to solve 11 to the power 2x minus 5 times 11 to the power x plus 4 equals 0, giving our answer to 2 decimal places. We can rewrite this equation as y squared minus 5y plus 4 equals 0, where y is equal to 11 to the power x. Factorising gives us y minus 4 times y minus 1 equals 0. So either y equals 4 or y equals 1. If y equals 4, then 11 to the power x equals 4. Or colour coding will allow us to see that a equals 11, x in green is as it is, and n is equal to 4. And this allows us to convert to logs. So x equals log 4 base 11, which when plugged into your calculator gives x equals 0.58. If y equals 1, then we have that 11 to the power x equals 1, and therefore x is equal to 0. So this is our other solution. And now for example 3. Find the solutions to 5 to the power x plus 3 equals 3 to the power x plus 1, giving your answer to 2 decimal places. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. If we log both sides of this equation, we have log 5 to the power x plus 3 equals log 3 to the power x plus 1. And then, using the power law, gives x plus 3 times log 5 equals x plus 1 times log 3. And expanding gives us this equation here. And finally, rearranging and dividing by log 5 minus log 3 gives us that x is equal to minus 7.30. We can check that this is indeed the case by plugging back into the original equation. So if we plug x equals minus 7.30 in, we can see that 5 to the power minus 7.3 plus 3 equals 3 to the power minus 7.3 plus 1. This brings us to the end of this session. If you have understood its contents, you should be able to solve equations of the form a to the power x equals b. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.